If you're new to solar and you know you want to build a 24 volt DIY solar generator, or maybe a 12 volt, or maybe you just don't know yet, then this video is for you. Right here beside me are all the parts you need to build a DIY solar generator. Now we're going to build a 24 volt in this video, but it also applies to a 12 volt. The only things missing here are the solar panels, of course. There's some connectors, the tools required, but we'll get to all that. One thing I'm going to do different in this video is that instead of just going through and showing you each part and explaining what it does and then build the system, I'm just going to start building the system. And as I add things, I'll explain what it's for and some more information about it. Let's get started. When building a DIY solar generator, most people, including myself, will mount everything to a piece of plywood like you see here. Now this is a 12 volt system I built 2 to 3 years ago. I did a video on that. I'll leave a link below in the description. And it looks quite a bit different than it used to because I've swapped out most of the components. But by mounting everything to plywood, first it's really easy to drill holes and mount it to the plywood, but second it makes it really easy to mount it to the wall, which is what most people do, a lot of people do. You just drill holes in the plywood, you hit the studs and you mount it to the wall and it works great. I've had this hung up for about a year where I powered a lot of things. But for the 24 volt build I'm about to build, I want to make something similar to this, but freestanding, to where I can move it around, maybe have a handle. I want it to stand up, maybe some kind of legs. I'm not really sure yet. I've got to figure that out, but I have some ideas. Okay, so let's start roughly laying out the components. What I'm going to do is I'm going to roughly lay them out here on this workbench. Once I get it all set the way I think it's going to be, I'll measure for a piece of plywood. Hopefully I can use just a pre-cut directly from Lowe's or Home Depot. I don't even have to cut it. So let's see. The first part we're going to talk about here is the solar charge controller. This is a Victron Energy MPPT solar charge controller. MPPT stands for Maximum Power Point Tracking. That's like the top of the line right now as far as charge controllers go. The other top is PWM, Pulse Width Modulation. They're a little bit older technology. Most everybody's using MPPT now. That's what we're going to use. The numbers here, Victron's like I think the only one that does this, but the 100 means 100 maximum volts input. If you go over that, you could destroy this controller. And we'll do all those calculations when we get to the solar panels. The 30 cents for it charges the batteries at 30 amps. So Victron Energy, high quality unit, extremely advanced settings that we will just barely go into. I think the default will get us most of the way. This is a 12 or 24 volt solar charge controller, not for a 48 volt system. Let me show you the data sheet. So as you can see here on the data sheet, the one on the right is a 50 amp version of this, but we have the 30 amp. It only works with 12 or 24 volt systems. And if you look down here at the solar input or PV input, photovoltaic is what PV stands for. It just means solar for our use case here. So we can have a maximum of 440 watts if we had a 12 volt system, but we have 24 volt what we're building, so we can have a maximum of 880 puts of solar input. We'll get to that in a little bit. So let's start laying this out. So one thing I noticed is that the PV input is on this side and the battery input is on this side. So I think I want to lay this closer to this side. That way I can have the breaker over here. Oh yeah, the breaker. So this is a DC breaker. It's a double pole breaker and this one is 16 amps. So I think the maximum is going to come in from the solar panels. I'll have to double check that in a minute, but I think it's less than 10. But this is a 16 amp double pole DC breaker. And the purpose of this is two things. If it goes over 16 amps, it will trip and protect the solar charge controller from some kind of short or something. But also, I can turn off the solar power just with one pull, and I can work on the system without any danger of getting shocked from the solar panels. So that's the purpose of this. And it's a DIN rail mount, which just means it we'll screw this piece of aluminum into the plywood and then this just snaps on. So we'll put that over here. The input from this comes in from the top actually, and the output will come out down here and go into the PV side. Okay, I think that's all I wanted to cover with the solar charge controller, but once it's doing its business, it will output on the battery side and we'll be running some wires to the battery through some bus bars, which I'm going to talk about next. Okay, so now we're going to talk about when the solar charge controller is doing its job, the output will come out these battery outputs here into this DC breaker. Now I want to have a breaker here because if something goes haywire with the controller and the amperage shoots up, this breaker will trip. And also a convenient way to switch off power from the solar charge controller. Now this solar charge controller I think has a protection for this, but basically you always want to turn off have the solar power input turned off when you turn on the battery first. Then once the solar charge controller started up, then you can turn on solar input. We'll worry about that later, but that's a general rule of thumb I always try to follow. Sometimes I've messed it up, but so far I've not burned anything up. So output will come out of the solar charge controller into this DC breaker. Now this is a 32 amp DC breaker, double pole. Same as the other. These have a maximum voltage of 500 volts, so we're way within spec there. And as I mentioned, it's 32 amp. The specification on this charge controller said a minimum fuse rating of 35, a maximum of 40. So I should really have a 35 to 40 range, but I think 32 will be okay. If I find that it's tripping when it shouldn't, I'll move up to a 40. I think that was the next size up. So okay, so output here into the breaker, and then output positive and negative we got coming to the bus bars. Now, what are bus bars? So these bus bars, let me just show you the negative one from the side here in the top. This bus bar here is rated up to, I think it was 250 amps and up to a 48 volt system, which we're going to have a 24 volt system, so it's well within spec here. So let me take off these caps here of the positive. These are a little protective cover here to keep something from accidentally arcing on here. So as you can see here, it's just a convenient way to connect different devices in one spot instead of stacking everything together. Now these little screws, which we'll actually be taking advantage of in a minute, we have a battery shunt, and it needs a power supply, and it has a little tiny wire that I'll just come in here and I'll tighten it down on there for power to power that shunt. So bus bars, convenient, safe way to connect multiple devices. So we're going to have the charge controller connected here. We're going to have the batteries connected on one, and we're going to have the inverter connected on another one with another spot open for if we want to put a battery charger on here or something in the future, we can always do that. So that is the purpose of the bus bars. So now what we want to do is start thinking about how the wire comes from the battery. We have a battery shunt, and the battery shunt, I'll explain that in a minute what it is. The battery shunt always on the negative side, so it'll sit here. And then the inverter, I think I want to build this more lengthwise since it's going to be standing up. I don't want it to be too top heavy, so I want to build it out more lengthwise than height. So I'll put the inverter probably here, and then let me just bring in everything and we'll start thinking about how this is going to work. Okay, so I've got pretty much most everything laid out here. Let me talk about the parts I haven't talked about yet. So let's start on this side and work this way. So these are what they call terminal fuses, battery terminal fuses. They go right on the battery, the positive side only, and it's basically, it protects the wire between the batteries and the rest of the system you connect it to. So I'll be connecting that later. This is a battery switch. This will go from the positive side of the battery coming in, and then you can isolate the battery. It's called an isolation switch. You turn on, and then the battery flows power. If you turn it off, then it shuts down power to the whole system coming to and from the battery. The wire will come off of that and come into this positive bus bar here. And of course the inverter, I'll talk about in just a second, but the wire will come off of here and go to the same bus bar. And as I mentioned earlier, the positive from the solar charge controller will also come here. Alright, so let's talk about the shunt. So here's the battery shunt, basically these four pieces under my hand right here. This is the little display that it comes with, and I'll show you that. And when I turn it on, it's really nice color display. I like it. And there is a wire that runs from the shunt sampler to the little display. I'll be showing you that. This is what they call a battery shunt sampler. And as you can see, there's a battery side and a load side. So the battery side goes to the battery, of course, and the load side will go to the rest of the system. And the job of this is that this little sampler here counts amps going in and out of the battery, and it gives you an estimated state of charge of the battery. So that's what it's good for. It shows you the battery voltage as well, but it gives you, otherwise you would have no idea, okay, how much battery's left. You don't know. So that's why this shunt's here. And to power this thing, That's the wire I mentioned earlier. I'm going to run to the positive bus bar to here. It says battery in the diagram. Oh, let me show you a little diagram. So we'll bring up this diagram here. And if you look here, this is a diagram I found on Amazon. It just shows the a little diagram of how the shunt connects in. So it's got the inverter on the top left. It's got the battery on the bottom left, the solar charge controller on the top right, and the little display on the bottom right. The little shunt sampler is right in the middle. And if you can see on the left and the right, there's positive and negative bus bars. And that's kind of how we're going to connect it. I won't go into great detail here because we're going to be covering that in just a minute. I'm actually going to hook it up this way. But that's a little diagram that helps explain how this works. Okay, so the inverter. Okay, that's another piece here. So I guess before I take this off, the inverter comes with a little display here, and it'll show us the stated charge. I'm sorry, not stated charge. It'll show us the battery voltage and the how many watts the inverter is using. And the wire that connects this display to the inverter is this Cat 5 cable they sent, which is way, way, way too long. I have another little short one I think I'm going to use instead of this one. But here is the inverter. It's, if I'm pronouncing it right, it's Jumpow. I did a detailed review on their 3080 12-volt version inverter and found it to be fantastic. So I chose this 24-volt version for this build here. So everything we've been talking about so far has been DC electricity, and that's what goes in on this side. Positive DC, negative DC. And that will connect here to the bus bar, the positive, and the negative will connect to the negative bus bar. And so all that, the solar charge controller will be pushing into the battery. This will be pulling from the battery. So it pulls in DC electricity and converts it to AC electricity, like we're all used to. These little 20 amp outlets here, 2 of them, that you can plug in your refrigerator or what, whatever, a hairdryer. This is for plugging in hardwired system like to your house. You can power your house with this thing actually. You plug it right in there. It's underneath a little cap there. Turn the inverter on and off here. We'll get into that later when we actually are using the system. But the purpose of the inverter, it converts DC electricity to AC so you can use it for your appliances. So that's the reason of that. So to give just a quick little overview of how all this runs and connects together, let me start at the battery side. So we'll have these terminal fuses mounted on the batteries, and there'll be the positive wire will come off of the, I'll actually show you how that hooks up in just a minute. The positive wire will be coming in here. When that's on, it'll run in power to the positive bus bar. The inverter will be hooked into the positive bus bar so it can draw electricity and power things. The negative will be connected into the negative bus bar. Let me continue with the positive. So battery, to the battery switch, positive bus bar. The inverter to the positive bus bar. The solar charge controller, remember the positive will come out and it'll connect in here. So all 3 will be connected to this positive bus bar. The negative bus bar, the battery will come into the shunt here on the battery side and come out to the negative bus bar. These will actually be up here. Then the solar charge controller, the negative will come out of it and run to the negative bus bar. And the inverter will have a negative cable come out and run into the negative bus bar. So that's this side. And of course, I've already covered this side over here. The solar energy comes in through the top, the wire comes out, and the solar charge controller comes out into the this breaker here, and then into the rest of the system. So that's the overview. Of course, I didn't cover great detail there, but I'll actually hook all this up and you'll see in just a minute. All right, so I was trying to source the plywood for this project, and I went to Home Depot and Lowe's, and it looks like 24 by 24 was about the smallest, the closest size I could get without buying a whole sheet. So 24 would have been fine height-wise, but not length-wise. This is greater than 24 here. So I was looking around in the garage, and hey, I found a piece of plywood. It's 22 by 42. Now 22 is fine this way, and the 42 is going to be too long width, but that's fine. I'll just cut it off. So I've reconfigured this. So let me go through this real quick. So the solar is going to come in here from the top. It'll come out the bottom into the PV input, out the battery into this breaker. The positive will come out and go to the positive bus bar. Negative come out and go to the negative bus bar. Okay, that's the solar side. Okay, let's do the battery. So this switch here you can, there's just one input and output, and you can move these little sides around and switch. So I'm gonna come in from the side and come out the top. So I'm gonna come in here and then come straight out to this bus bar. And I already checked the bus bar and to make sure lugs would fit in the end, the size that I think I need to be using. So yeah, so that's no problem. So it's going to come straight out right into the bus bar. Now the inverter, positive, is going to come straight out and go right to the positive bus bar. So that's good. Straight runs. That's good. Now for the negative side. So the negative coming from the battery is going to come in here to this battery side of the shunt. It's going to come off of here and go straight into the bus bar. And then the inverter is going to come straight out and go right into the negative bus bar. So I think that's going to work out good. All straight runs. I don't have to curve the bigger wires. I may end up going with a larger wire just in case I want to upgrade. And speaking of upgrading, I was looking, I have another 24 volt inverter that's longer than this one, 17 inches. I think this one's only like 13 or something, so it's longer. So I'm going to put some extra room, extra space over here in case I want to either upgrade or use that inverter for some reason. So I think we're good here. Oh, and this little wire here is going to come off the shunt and just fish through here. Shouldn't be any problem connecting into this positive bus bar. All right, so let me get the plywood cut to length and let's get started. Okay, so I got the plywood cut. It may just be a little bit long, but that's okay. I think it's going to be good vertically. I'm ready to start hooking things up, and I got to make the wires to do that. You could buy custom wires and have it, custom made the exact lengths you need, but you got to come up with a wire size, and safety is utmost importance there. You got to make sure you choose the right wire size, or you could actually have a fire, and we don't want to do that. So we're going to make sure we have the right sizes to make it safe. And so we got 3 sizes we got to worry about here in this system. We got one that comes into the breaker and into the solar charge controller. That's one wire we got to worry about. Then there's another wire that runs out of the solar charge controller through this breaker to the bus bars. That's a second size we got to worry about. And then the last size is the one that goes from the inverter to the bus bar and the battery through the switch to the bus bar and the shunt into the bus bar. That's the last size. And as a matter of fact, I'm going to just cover a quick little lesson about the wire sizes that I'm going to choose and how I come up with that. Okay, so the first type of wire we're going to talk about sizing is the PV solar wire, and that is the wire that runs between the solar panel and the solar charge controller breaker. So that's a different type of wire. It's the other type of wire we're going to be considering is battery and welding wire, and that's the type that goes between solar charge controller and the bus bar and the battery and the inverter in the bus bars. But this wire is different. It's got different jacket material. There's other things different about it. So it's got a different ampacity than what we're going to look at. So when you're shopping for PV solar wire, you'll see it in 3 gauges, typically 12, 10, or 8. And the AWG here at the top stands for American Wire Gauge. 8 gauge is less common. You won't see it as often. If you're looking for connectors, it's hard to find sometimes, but you usually find it in 12 gauge or 10 gauge. So I think I have 12 gauge, and I'll double check, but I'm pretty sure it's 12 gauge. And that says here current rating up to 30 amps. So if we look at the solar panel I'm chosen for this project, I know I haven't covered it yet, but I'll be bringing it out and covering that later. It's this Bluetti PV350. It's a 350 watt panel, and if you look at the very bottom, the short circuit current, and that's what you use to calculate this, is 10.8 amps. And that is well within the 30 amps. So that is the size wire we're going to use for the wire from the solar panel to the solar charge controller. Okay, so we just talked about the PV solar wire that runs from the solar panels to the solar charge controller. It's a 30 amp charge controller, and we decided on this 12 gauge solar wire here. But what about the wire from the solar charge controller to the bus bars? So to do that, a very, very common chart to refer to is this ampacity chart by Blue Sea. Blue Sea is a company that makes a lot of very good equipment. As a matter of fact, I'm using their terminal fuses in this project as well as their fuse holders. So let's look at this chart and figure out what it means here. So basically this this first row here is saying this is how far of a run you're going to make. So we have very, very short runs. So between the battery and the battery switch is probably, and the battery shunt is probably going to be the longest wire, and that's not anywhere near 6 feet. So we're going to be using this top row right here. And what this is this is the amperage that goes across the top. And as we just said, that's a 30 amp charger. So there's 30 amps, and it says you can use a 10 gauge wire. But if you remember, and I couldn't find in the manual the exact wire size you're supposed to use, but the fusing in the manual said, I think it said 35 or 40 max fuse. So it could possibly go up to 40 amps. So I'm going to choose an 8 gauge wire to be sure. So in case you're not familiar with this, the smallest on this chart here is 16 gauge. And then it goes, the lower the number, the bigger the wire. So let's just use this column here as an example. 16 gauge, and then it gets bigger at 14, 12, 10, 8, all the way down to you get to, let's move over here, to like say 2 gauge, and then you go to 1 gauge. Now 1 gauge you rarely see, actually. I don't even think Windy Nation sells that. I'm going to be talking about that in a minute. But and then once it goes to 2 gauge and it gets the next biggest size is typically that you find is 1 aught. And that's what aught being 0. So 1 aught, 2 aught, 3 aught, and 4 aught being the biggest wire. So for the 30 amp charger, and I'm going to go up to 40 amps to be safe, I'm going to choose 8 gauge wire between the solar charge controller and the bus bars. Okay, so for the battery inverter wire, if you remember, we have a 2080 watt inverter, and the battery is going to be a 24 volt battery bank. And the way you would typically calculate the maximum number of amps you would be using is you take the max size of the inverter, which is 2080, divided by the battery voltage, and that would equal the number of amps, 86.6. But as you may or may not know, inverters can sometimes go over their rated capacity. So a number I've seen commonly used is 30%. So if you take 2080 times 1.3, you get 2704 watts. So if you divide 2704 by 24, you get 112.6 amps. So if we go back to this ampacity chart by Blue Sea, we had 112 amps. So if we, and again it's short, so we use this top row and we go across to 112. We don't want to be right at any number, but we're comfortably between 100 and 120 here, at 112. So we could use 2 gauge wire. And before I make a change here, I want to mention something to you. Okay, so this is Windy Nation's website, and it shows the specifications of their wire. And if you can see here, actually let me zoom in. Their 2 gauge wire has a maximum amperage of 205. And that's different from this amperage chart you saw here, because this shows the safe usage of, and this is showing you the absolute maximum amperage right before the wire starts failing. So you don't want to get anywhere near this. So I just wanted to show that to you. But let's go back to this chart here. So even though we said we can use 2 gauge wire, as I mentioned earlier, I may decide to upgrade that inverter. Maybe it's a bigger inverter. So if I do that, I'll be right at the capacity. So I think I'm going to jump up to the next wire size just to give me some extra room there. So the next wire size says 1 gauge. Well, there's not. Windy Nation doesn't even sell 1 gauge, but they do sell single aught or 1 aught. So I'm going to use 1 aught gauge wire for that part of the build. As I mentioned here, 2 gauge, but we're actually going to use 1 aught. Just here, I'll just mark it here. 1 aught is what we're going to use between the battery and bus bars and the inverter and bus bars. Okay, so now that we got the wire size determined, I brought out my 1 aught negative wire. I'm going to start with it. So as you can see here, this is 1 aught wire, and I'm going to start here on the inverter to the bus bar and the battery shunt to the bus bar. Let me bring in a little closer. Okay, so there's a couple things we have to think about here. So most everything here is 5/16. So these bolts here on the bus bar are 5/16. The bolts on the inverter are 5/16. But we have 2 things that are 3/8. The battery shunt and the battery switch. Both of these are 3/8. So when we build a wire, we need to make sure we use the right lugs. Now, I'll do a close-up so you can see this better, but these are the lugs for 1/0 5/16 and 1/0 3/8. So the inverter here has 5/16. The battery, the bus bar has 5/16. So we'll need to make sure we use 5/16. I have a 3/8 here, and one more thing to think about is that this wire is going to go on at an angle to the side, and this is going to go at a 90-degree angle up and down. So when we build the wire, we need to make sure we build it to where this one's sideways and this one's up. And at short of run like that, you'll never twist it if you build it wrong. And one more thing to think about is the distance between this lug and here. This is higher than this. Now, if we use too short of a wire, it'll be really hard to drop down and get that wire flat enough to where it will screw down correctly. So I want to make a little bit longer wire. Now I could raise this, but then I'll have to start worrying about everything else. So I think I want to just build a long enough wire to where I got enough space to drop it down and make it go flat right on here. Okay, so there's that. So now what I'm going to do is I'm going to kind of build one wire. This is not a video about building wire, so I'm going to go kind of quickly. I'm going to build one wire, and then I'm going to just use, I guess, time-elapse and then move around and build all the rest of the wires. Okay, so I just kind of roughly measured here and cut the wire with this big heavy-duty wire cutter I have here. And that looks to be about right. So I'm going to just temporarily move the inverter out of the way so I can show you what I'm doing. Alright, so I don't have the nice wire strippers where you can stick on there and just spin them around and it trims this off really good. I don't have one of those, so I'm just going to show you what I do. And this works, and experienced people, go ahead, you can laugh at me, that's fine. But if you see here, it's like a cup up in there. I don't know if you can see down in there, but it's like a cup. So you don't want to strip it back too far, but you want to strip it back enough to where the wire can get in there deep enough to where when you crimp it, it'll hold. So that should be right about there. So let me start cutting here. Now you don't want to cut, I'm just cutting very lightly. You don't want to cut so hard that you end up cutting strands of the wire off. Now if you do that, you could actually mess up. You probably all start over, but if you cut gently, you can kind of feel when it touches the wire and you can stop. But if you start cutting strands, yeah, you kind of almost ruined it, and I'm not cutting straight here. Let's see if I can get that off. And I didn't cut a single strand off, so that's good, but it looks like it's a little long. It's 5/16. Let's see here. See if I can get that on there good. Show you what I'm doing. Actually, that's okay. So this is a 5/16, and if you remember, I needed another 5/16. Let me get one. And if you remember, I need to have this one turned sideways. So let me go ahead and strip this off here. Okay, so I did not cut a single strand of copper off. That's good. That's what you want to do. Alright, so I got two 5/16 lugs, and this one's going to go in here, and it's going to connect to, whoop, see, you don't want to do that. Did you notice that? I pushed it in, you have a strand, I don't know if you can see that, but there's a strand of wire coming out. You want to make sure don't twist too much, but you want to make sure, and if you push too hard, you'll push it out the other end, so you want to make sure, and then the short wires especially. So let's make sure every single strand gets inside that cup for that. Okay, there we are. So it's in there. Let's get the other side on. Make sure every single strand of wire is in there. Okay, and it is. Alright, if you remember, this one goes on sideways and this one's got to go down. So there, as you can see, there's a flat part. That flat part goes down. This flat part will go against the inverter. So we're going to go in sideways like this, and this one's got to go straight down. So now I'm going to get my crimper, Now I bought a hydraulic crimper. I wish I'd bought a little bit better one, but it works up until 1/0 wire. When I get to 2/0 wire, my hydraulic crimper does not seem to work very well, especially on this tin coated. So let me get that. So here's my hydraulic crimper. I've already got the 1/0 dies in there. Move this out of the way. And let's get the first one on first, and then I'll make sure it's twisted correctly. Gotta make sure you make contact first and then make sure it's pushed in there good. Okay, now we're in. Now let's go. Just keep pumping. Keep pumping until you can't go anymore. I usually have to put my body weight into it. Now, I might be marring up the surface of this, but that's okay. I think that's good. As you can see, that's a hydraulic crimp, and that's, if I did it right, that's not going to come off. So let's twist it this way, and this one needs to be going straight down, just like that. So maybe I gotta make sure when I get it in there and get it going, I need to make sure it's correct. Tighten it back up. Alright, it's correctly oriented now. Start going. Okay, so that is good. Just a little bit of copper showing, but we'll be covering that up with heat shrink. So have this facing this way, this is facing down, so we're good. Let me get the heat gun and the heat shrink. Okay, I didn't have my microphone on, I just had it laying here, so hopefully that previous scene is not too bad. But I got my heat gun going here, and this looks like this heat shrink is long enough that I can make one piece into two pieces. Let's give it a shot. So I'll put the heat shrink on, and just slide it on. One on one side, one on the other. And it needs to be positioned to where you don't want it way over like that, to where it starts getting in the way of the connectors. You want it just out of the way like that. If you can see that, just out of the way to where it's not going to interfere with it laying flat. Let's get the heat gun on. Let's drink it up. It's moving around on me. There we go, that's okay. Those short wires kind of hard to not get in the way of the heat. Alright, so there we go. A built wire. Okay, now that I got the wire built, I'm going to kind of test fit it here. I've taken these nuts off. So since we're dropping in height, I'm kind of going to try to bend this wire. I've already bent it a little bit, just into shape a little bit, to where it's kind of dropping in height, and then this is flat. You don't want to do it too much, but let's test fit it here. Looks like I made the wire just a little long. That's okay. We didn't tighten anything down yet. So one thing you want to do is you always want to put the flat washer on first, then your lock washer. Now I'm not tightening anything down, I'm just testing, but this is not even the right, this is that goes on the other lock washer, yeah. But yeah, it looks like this wire is going to be fine. I wish I'd made it ½ inch shorter, but that's okay. Let me get to making the rest of the wires now. More piece of advice before I forget. always put the wire lug or whatever you're connecting directly against what you're connecting it to, like this. You don't want a washer in between. Never go through a washer. So as I mentioned earlier, flat washer against the lug here, then the lock washer. And another thing to make sure is when you're tightening, sometimes these washers can get kind of kinked, and you might tighten it down like that, and that's no good. You want to make sure, of course I'm just barely thumb tightening it now, but make sure it's completely flat like that when you make your final tightening. So I did make a mistake, and I wanted to share that with you because everybody makes mistakes. But when I just made this wire, I made it to where this was facing the same way, and not thinking, but the battery is upside down, so I needed to make it this facing down and this one facing up, so I had to remake that wire. Well, there's been a development. While trying to tighten this bolt under here, the nut under here, I ended up breaking the little housing piece right there, and I'm going to replace it with this Blue Sea switch, which I think is a much better one. I've used this one on another build, and I really like it, so I'm going to be replacing that. Let me see if I can get in here and show you where it broke. I don't know if you can see that, but it broke right there, that plastic, and it's bowed out right there. So I'm no longer going to use this. I'm just going to trash this. One problem with this Blue Sea switch is the wire can only come in and come out, or vice versa, but so it can't come out the side. So at least I can't figure out how to do that. So I will have to just, when I put in the legs or whatever I do to hold this up, I'll just make sure I have to work around this wire coming out here. Between the solar charge controller and the bus bars, if you remember, we're going to use 8-gauge wire. Found some, but these ends already had these ferrules crimped on. Ferrules basically come in these packs like this. As you can see, they're just little round things, and then you use a crimper like this one and put it in there and then tighten it, and it puts on these ends real tight on this over the stranded wire. And the purpose of that is to keep any strands from going astray, basically. So if you accidentally crammed it in the solar charge controller and a strand was sticking out, well, you possibly got a chance for a short there. So this keeps that from happening. The only downside to these is when you're tightening them, you need to tighten them good, then give them a little wiggle, tighten them again, give them another wiggle, and tighten again, because that's sometimes they can come loose a little bit when you first tighten them down. So you just need to make sure you get them good and tight in there. That's the only downside. Everything else is upside. And one more thing about these 8-gauge wires is earlier I showed you how to strip the wire on the end with the basically utility knife. But for smaller gauge wire, I do have strippers for that, and that makes it a whole lot easier. So there is a 6-gauge and 8-gauge are the two biggest ones on this one, and I do use it for that. Okay, so the wiring is complete. I've cleaned things up. I did end up putting a little 2-amp fuse here on this wire coming from the battery shunt because I think all wires should be fused. I put it as close as possible to the source, energy source here. So what you want to do now, which I've already done for some of this, is double check everything. Double check, triple check. Make sure all negatives are connected to negative. And I've already gone through and done this, but negative, 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 and then do positive and go through every single thing and make sure, like I accidentally had this positive wire connected to the negative bus bar early on, and then I of course noticed it and fixed it, and then I forgot to tighten this wire, but I caught that. Anyway, make sure everything's good and tight, test everything very well. Now these kind of move around a little bit because they slide around on this DIN rail here, but I checked all the wires are tight, everything's good, all the positives are where they should be, all the negatives are where they should be. Now it's time to put on the safety caps. I've already put the ones over here on the inverter, just to keep anything from accidentally shorting out in between these. The battery switch is off. All these breakers are in the off position. That's what you want. Everything should be off before we try to hook a battery to it. So now I'm going to move this out of the way and pull in the batteries and show you the batteries and what we're going to use here. So these are the batteries we're going to use in this project. These are two 12-volt 100 amp hour batteries made by DC House. They're lithium iron phosphate. I recently did a review on these batteries. If you want to see that, I'll leave a link here at the top of the screen, and down in the description I'll put a link to that video. I encourage you to go watch that. Okay, so these are lithium iron phosphate. These come around the last few years, and this is pretty much what everybody's using now when they build their own solar systems. So that's what we're going to use here. Now, we just built a 24-volt DIY solar generator, so I could have used a single 24-volt battery, but I had these two batteries, and all we have to do is wire them in series to bring that up to a 24-volt battery bank. So if you hook them in parallel, which I'll show you, it would stay 12-volt. But if you hook them in series, it brings it up to 24-volt. Let me show you how that works. So here I have these batteries wired in parallel. So this is the positive, negative, negative. I've got those hooked like that. So if I were to run this to a solar generator, I would hook the negative here go to the solar generator, and the positive off this one to go to the solar generator. So let me show you how, when they're wired like this, this stays at 12 volts. Now, 12 volt is the class, 24 volt is the class, 44 volt is the class. So the wire, it doesn't mean this voltage is going to be exactly 12 volts. It means it's going to be a range of 11 point something up to 13 and a half roughly. That's the range of a 12 volt. So let me just show you here. Okay, so I've got the negative, I've got a multimeter here and got it connected to the negative on one battery and the positive to the other here. And hopefully you can see that, but it's 13.31 volts. All right, so now these batteries are wired in series. So we have the positive of this battery hooked to the negative of this battery. So this positive will go to the DIY solar generator, and this negative will go to the DIY solar generator. Now, it's hard to do this with just laying these in here, but maybe it'll work. I just want to show you the voltage is now 26.64, which is in the 24 volt class, and that's what we have now with these batteries wired in series. One important thing to do when hooking batteries in parallel or series, make sure they're both fully charged so they start out at the same state of charge. This battery has a neat little feature here that you can actually see the state of charge, even though I know I've already charged it and it went as far as it could on the battery charger, that it shows you the estimated state of charge based on here. But I do know that these are both fully charged. Alright, so I have everything hooked up here, and before I did any of this, I made sure the battery switch was off, the inverter's off, these breakers around the solar charge controller are off, batteries wired in series for 24 volt. I got this temporary 2-aught wire here that I'm gonna build a 1-aught wire just for this system. The negative wire is coming out here to this negative, the positive wire is coming out of the battery switch to the positive. I have a 100 amp terminal fuse right here on this battery coming out of the positive. So let's turn on the battery switch. I'm not going to use a precharge. I'm not going to use this little resistor to precharge capacitors in the inverter. If you don't have a battery switch and you just connect that last connection to the battery, you're going to get a big spark. But if you use these little resistors to do the connection first, and it precharges the capacitors in the inverters, and you won't get no spark. Now, if you had the inverter turned on and you just turned it off and reconnected, it's not going to spark because those capacitors are already charged. But over time, they lose their charge, and you'll get that spark. But if you have a battery switch, you don't have to worry about that. All right, so let's turn on the battery switch. I don't expect anything to happen, and it didn't. Although the screen came on for just a second. Let's see if I can capture it. It goes dim when there's no power flow, and it just went dim, so it's kind of hard to see. So that is your battery monitor, battery shunt monitor. So now let's turn on the inverter. It'll just beep, and that should show us the screen again. All right, so the inverter is powered. Let's just double check it's actually creating AC power like we think. I've got this scroll saw here. I'm just going to connect it in real quick and turn it on, make sure it's working. We're working, we're good. Let's turn on the breaker from the battery to the solar charge controller. Now I don't have solar hooked up yet. Okay, it's blinking, so it is working. We've got to configure that in a minute with the mobile app because there's no way to configure it. Let's see, it should be blinking bulk. There it goes. All right, so that was just this quick connectivity test I wanted to do. Okay, so I've got the batteries hooked up in series. I've created this 1/0 wire here, which is a little longer to where I can move the batteries around different positions. And I went ahead and hooked up the second terminal fuse. I've read it's not necessary, but I just went ahead and put it on there anyway. And one thing I forgot to mention is proper torquing. Everything should be torqued properly, and you should look up each thing what should be properly torqued. But I've not always done that. I kind of got a feel for it over time. But like this one, specifically, it says a maximum of 8 Newton meters per for the terminal studs. So let me get that to. Okay, that went just a little bit over. See, this other one's not tight either. We'll do it a little bit more. Okay, here we go. About 7.9. This one got it right about 8. All right, so these terminal fuses are now properly torqued. Put on a little protective cover. I think everything else is tight. And we just need to hook up the negative. What I'm going to do now is hook up the solar. But let's go ahead and I'm going to configure the solar charge controller first. The battery switch was turned off. That's important. So let's see. Let's get this properly torqued as well. Okay. All right. So now I'm going to configure the mobile app. I'm going to configure the solar charge controller using the mobile app. But first, got to turn on the battery switch and the breaker. Okay. So this is the Victron mobile app. Usually when you have a new device from Victron, you have to go through a setup process, but I previously have used this, so it's already set up on here, so I don't have to go through that. So let's select it. It's opening. I see lights blinking on the solar charge controller itself. All right, so it's showing the battery voltage, which is 26.64. That's good. Let's click the little gear icon. It looks like there's probably a firmware update to be done. I'll do that off camera. But let's click the battery, and yes, we are set at 24 volt, maximum charge current of 30 amps, and it's enabled. I'm just going to let this default take on everything else, and it's ready. So we are ready now to hook up some solar to this solar charge controller. This is the foldable solar panel I've chosen to go with. Let me get it hooked up. It's not the best day for charging, and it's mostly cloudy and late in the afternoon, so this is not really the best time, but I'm gonna get it set up anyway. I'm gonna leave it folded for now until I get the wires hooked up. Okay, let's fully open this up. All right, let's go see what it's doing inside. All right, so we are back in the garage now. I've hooked up the solar wire from the solar panel in here to the breaker. Now let's turn on the breaker. We are now on. It says bulk charging. Let's take a look at the mobile app that I see here. Okay, let's click that. It slowly ramps up on the wattage. All right, showing here we're charging at 200, and it's just bouncing around obviously because it's cloudy out there, but almost 300, 280, 285 I saw. The amps bouncing around too, 5 to 7 to 8 amps. So we are definitely charging. Let's take a look at the batteries. They also are Bluetooth and have mobile apps. All right, so the battery 66F3 is the one on the right. So let's take a look at that. I was incorrect. I thought both batteries were fully charged, so this one was not, but it won't take long. As you can see here, it's charging at 10.3 amps, or a total power down below of 137 watts. 93 amp hours. Let's go to the other battery. Okay, this is the battery on the left. And I know that because of the barcode on top. Alright, this one says 100%, so I should have charged both to 100%. I should have double checked that. I didn't, but it won't take long for this to fully charge since it's almost fully charged. This one's also bringing in around 10 amps, even though it says it's 100% charged. So that's 100% state of charge, even though it's probably not accurate since it's bringing in 10 amps. Alright, so we are off and charging. Here's the battery shunt monitor here. I went ahead and set it for 100 amp hour because we have two 12 volt 100 amp hour batteries for a total of 200 amp hours in 12 volt, but since it's a 24 volt bank, it's 100 amp hours. So I went ahead and used the manual here. Let's see if I can pull in the instructions here. I've used the manual. There's instructions here on how to do this, but I've set it to 100 amp hours and to 100% state of charge. Now, we're not actually at 100% state of charge yet, as we know from the mobile app on the batteries, but we will be soon. And once that is reached, I'll make this will actually stay maxed out at 100%. And then once it starts dropping, then it'll start dropping on this monitor as well. So I just need to make sure I charge the batteries to 100%. All right, so this is the Zhongpao 2080 watt 24 volt inverter I mentioned earlier. I have a flashlight shining on the side here so you can see this better. But the main power switch can be either off in the middle or on the top, the bottom, the left. Or the way I have it set right now is it's set to where the remote control display controls it. There's a USB port. Here's the LAN input that connects the wire to the display. And there's dip switches right there. And I have set those to where there's the one on the top is the one that sets it between 110 volt and 120 volt output. So I have it set to 120 volt right now. So let's see what we got. Yeah, 120 volt AC output. All right, let's do a little test. I have this LG portable air conditioner I have in the garage here. The output's to the side of the house. It runs about 950 watts roughly, so I'm about to run that through the inverter. So I plugged the air conditioner in. It's now running. I hear the fans on the inverter have kicked on. Let's take a look at what the screen is showing us. It looks like it's pulling 855 watts. I thought it was 950, but it's 850. And let's just move over here to the battery display, and you can see it's pulling 900 watts out of the batteries. That's because the inverter takes a little bit of power too. That's the reason this display is showing a little bit less. So it's taking 20-something watts just to run the inverter, which is absolutely normal. Now let's take a quick look at the mobile app. All right, so we have, let's check out the first battery. As you can see, it's drawing 463 watts out of that, or 35 amps. Let's take a look at the second one. It's taking about the same, 35 amps, 400, varying, but 460, 470 watts total power out of each battery. I've now plugged in this little space heater and put it on low. As you can see here, we are pulling 2,045 watts out of this 2,088 watt inverter. So we are pretty much maxing this thing out. And that's what we want to do. We want to run this for a few minutes and then check, see if anything's getting hot, except for the heater, of course. And if it's getting hot, it could be a loose connection. It could be a bad connection. It could be a bad crimp. It could be that you're using a wire that's too small. There could be all kinds of things. So this will be a good test. I'm going to let this run another 2 or 3 minutes, and then I'm going to check for heat. Hope you can see this, but during that last test when I was maxing out the inverter, I must have went a little too far over, and these 100 amp fuses, the one on the right kind of partially started to melt, but the one on the right one on the left burnt all the way through. So I needed probably 125 or 150 amp. I have 200 on hand, so I'll use those for the remainder of this test. Alright, so the air conditioner is running no problem. I have now brought in this space heater, turned it on low, and I've been running it for about a minute or two, and it's just over 2,000 watts. And what I'm going to do is run it here for just a few minutes and then check for heat. While we're doing that, let's pull up the mobile app. If you can see here, it's drawing 76 amps from this battery, and it's drawing 76 amps from that the second battery. A minute ago I was running the same test, and the terminal fuses on the battery, the fuses burnt through. They're 100 amp fuses. I thought I bought Blue Sea fuses, but they were actually Bojack, and that's not as good as brand as Blue Sea. Blue Sea would probably have held up, but I have 200 amp fuses here because that's what I just happen to have. I should probably have 125 amp fuses here. So let's run this just a minute more, and then I will check to see if there's any heat. Okay, so I just switched off the air conditioner and the heater, and I've turned on my my mobile phone. I've put on the thermal imager. So let's check for heat. Now this is going to jump out to you like it's really, really hot, but let's see how hot we're talking. So the heater looks like it's 135, 136, I thought I saw 186 there. But let's see here that these terminal fuses looks like they're getting up to 105, 150, it says 158. Now let me put my hand on here. That's pretty warm. But not so hot that I can't touch it. See how hot my hand looks. Now that one's not so warm. This one is more warm. Why is that? I don't know. I have to check that out. But let's see all these other. The wires look great. The inverter's a little bit warm right there, but not much at all. The wire says it's 83. Yeah, that's really nothing. This wire says it is 86, which is, again, doesn't even feel warm at all. This is not warm. The battery switch looks perfect. Let's check this wire down here. It says it's 85, which is nothing. But this terminal fuse here, why is that getting so hot? We got to figure that out. This one over here did not. It feels actually cool. It's slightly warm right there. But this one, for some reason, did I not tighten it down? It feels all tight. So I'll have to figure that one out. All right, I figured out my stupid mistake here. Let's see if you can see it. See what I did? I accidentally left the lock washer on when I put the battery lug on. So the lock washer is in between the fuse and the battery lug, which was a dumb mistake. Let me fix that. Okay, so I fixed it. Let me show you what I did. I got the battery lug now is directly against the fuse, the way it should be. These foldable portable solar panels are very convenient. You can open them up, you can move them around, you can take them with you, whatever, but they do come at an extra cost. This one 350 watt panel I think cost over $700. So an alternative to this is rigid solar panels. They are much cheaper, but they are heavier, they're harder to move around, and one benefit is you can leave them out year-round. So here are 3 rigid solar panels from Renogy. They're 200 watts each. So I have them currently wired in series, just like we did the batteries, with the positive to the negative. And they're combined for a total of 600 watts. And the open circuit voltage on these are 23, I believe. And combined, that's up to just under 70 volts total. If you remember, that solar charge controller only takes 100 max. So we're well within that. So let's go ahead and see how much these are pulling in. Okay, we're back in the garage. I've just flipped on the breaker to the solar charge controller. I'm going to connect to the mobile app now and show you what it's showing. As you can see, we're bringing in 436 watts of power, which is good. It's a maximum of 600. It's hot outside, so you're not going to get anywhere near the maximum. If it's colder, we'd get better, but you rarely ever see the full maximum amount of 600 in this case. For the stands to hold up this, if I want to move it around and put it like in the garage in different places or something, I built these very rudimentary stands to kind of just slide the plywood right down in between these. And then I could just store them away. I could put it on a wall. I could still lay it on here. It's a little more flexible that way. Let me show you how it goes in. So to slide the solar generator in these little stands I built, you just simply pick it up and drop it right in. And it does lean forward just slightly, but that's okay. Maybe I could slide a shim in here or something to hold it up straight if I wanted to do that. It's simple, but effective. I hope it's not too loud, but I actually wanted to close out this video while actually running the garage air conditioner with this 24-volt DIY solar generator. The build is pretty much complete. I need to do a little bit of wire management and cleanup and securing of some of the wires. I did mount this inverter display up here. I thought it was a pretty good place, and the battery shunt display. The build is pretty much complete. I did run the test, a third test with checking for heat, and it went with flying colors, no problems with heat anymore since I fixed this issue that I found. That's what testing is for. Any component that I've used during this build and any video I've referenced, I'll be sure to put the links down below in the description. I'd like to thank DC House for providing these batteries and Jung Powell for providing the inverter. Fantastic inverter, fantastic batteries. I believe that'll do it. I appreciate you making it all the way to the end, and thanks for watching.